In this first practice, we are going to analyze the Archimedes principle, as well as its relationship with the density and the flotation phenomenon. The Archimedes principle states that a body wholly or partially immersed in a fluid experiences a buoyancy force upward equal to the weight of the displaced fluid. In this case, the concept of pushing force is of great importance, and we will explain it below. Suppose we have a container with some initial volume of liquid, and we place inside of it an object. The first thing we would see would be an increase in the liquid, so we will have the displaced volume will be equal to the volume of the object. On the other hand, the object is subjected to an atmospheric pressure if the container is open, but also to an hydrostatic pressure due to the liquid. This pressure will be calculated as the product of the fluid density by gravity by depth. The depth will be measured from the surface to the point where we want to know the pressure. By definition, we will have that the pressure is equal to the force over the area. If we made a clearance, we will have that the force will be equal to the atmospheric pressure plus the product of the density of the fluid, the gravity, and the depth, both pressures multiplied by the area. If we develop this equation, we will have that the force applied to the object will be determined by the fluid characteristics, the density, and also by the depth. If we think in the forces that are applied in the sides of the object, both of them will be in the same pressure. This means they will have the same magnitude. As they are in different directions, both of them will be zero. But what happened to the upper and down face of the object? We will have that the force applied to the upper face is on a depth h1, while the down face is on a biggest depth we call h2. Of this, we can conclude that the force applied to the down face of the object will be biggest than the one applied on the upper face. Now, when we determine the resultant force, called buoyancy force, we are going to have that the buoyancy force will be equal to the down face force minus the upper face force. If we develop this formula, we will have that all of this corresponds to the down force face and all of this corresponds to the upper face force. We eliminate the equal terms and finally we will have the following. In this equation, we can note that in both terms they are in the same density, gravity, and area. So, if we made a reduction, we'll have the following. We can see that when we made h2 minus h1, we calculate the height of the object. So, when we multiply by the area, we can obtain the object volume. This volume is equal to the displaced volume. So, we can conclude that the buoyancy force is equal to the product of the fluid density, the gravity constant, and the fluid volume, that is equal to the object volume. Also, we know that the density of the fluid multiplied by the volume gives us its mass, and if we also multiply it by the gravity, we will have the buoyancy force is equal to the weight of the displaced fluid. This has great importance because this pushing force is very important in the flotation phenomenon. As mentioned above, the flotation phenomenon depends a lot of the buoyancy force, which is equal to the weight of the displaced fluid and can be calculated as the product of the fluid density by gravity by the displaced volume. However, at this point, we will emphasize the concept of density, which is defined as the amount of matter that has a body per unit volume and is a measure of how much is the matter concentrated in the body. This concept is very important because, as we have said, is related to the buoyancy force, but also it will be related to the weight of the object and it will determine in a very important way the flotation phenomenon. Consider this. We have a balance in which in one side we put the volume of the displaced fluid, which corresponds to the buoyancy force, and in the other side we place the object. If the density of the object is greater than the density of the fluid, even that having the same volume, the weight of the object will be greater because it has higher amount of matter concentrated in its body. Therefore, the buoyancy force will be smaller and the object will sink. On the other hand, if the object has a lower density than the fluid, even though both volumes will be the same, the fluid will have higher amount of matter concentrated and therefore its buoyancy force will be greater than the weight of the object. In this case, the object will float. What would happen if the fluid density is equal to the density of the object? Think about this case and give an example for each one. Once we have talked about the principle of Archimedes and the principle of flotation, as well as related concepts as density and buoyancy force, it's important to see that in practice. First, we have to analyze the principle of Archimedes by calculating the buoyancy force. For this, we will use a force sensor and three different objects: a copper cylinder, an aluminum cylinder, and a sphere of lead. We will hand each of these objects in the force sensor to measure its actual weight. Once this is done, we will place each object under a recipient covered with water. This in order to measure the appearance weight of each object. The buoyancy force will be equal to the actual weight minus the apparent weight of each object, while the theoretical value will be equal to the weight of the displaced fluid. In other relationships, it will be equal to the product of the fluid density, the gravity, and the volume displaced. This last one, we will get it by measuring the volume of each of the objects using a vernier. Once we have both results, we are going to calculate the error percentage in order to get some conclusions from these results. In a second experiment, we will make an analysis of density. We will have a set of bars, where we can distinguish two colors, gray and opaque. The first step will be separate each group by color. Then we will have to arrange tables, arranging from the lowest to the highest according to its mass and volume. Once the data is captured, we will make a graph, plotting mass against volume. This will give us a straight line. The slope of the line, we will call it experimental density. Following that, we will have to compare the experimental value with the theoretical value of density. The last one is going to be provided by the professor. We will get our error percentage in order to get some conclusions from these results. Generally, this is what we are going to do in this activity. The details of each experiment may be consulted in the document practice.